Ladies and gentlemen, today I'm very pleased to have an opportunity to share a case study to you. At last Congress, ZTE got a 5G Excellence Award, which is ZTE Common Edge solution. With the advent of the 5G year, many new technologies are emerging, among which edge computing technology has become a key scenario application technology for the digital transformation of 5G industry. Different industries has different demands. Applications such as AR, VR, V2X that requires low costs needs to transfer of computing capabilities to the cloud. Latency-sensitive applications such as cloud gaming, industrial control, and intelligent decision systems requires transfer of computing capabilities to the edge. To sum up, it's necessary to find a balance point with low costs, low latency, and high computing capability on the cloud and edge side. Edge computing includes three main factors: connection, computing, and capability. To build an open and integrated edge computing platform, the following three architecture requirements must be considered. ZTE Common Edge solution is an open MEC ecosystem including full series MEC servers, adding hardware acceleration cards, lightweight edge cloud, edge network, and open API to third-party applications. The hardware layer is compatible with full scenarios, including fixed access equipment OLT, RAN equipment BBU, and third-party MEC server. The performance of hardware acceleration should be increased up to 10 times. The lightweight edge cloud uses AI algorithm and dual-core OpenStack plus Kubernetes to improve 5G service performance and simplify O&M. Light edge cloud by mixed deployment of container and virtual machine introduce rich cloud native technology stacked to assist the ICT edge application for faster distribution, deployment, residency, and cross-cloud migration. It provides a centralized API distribution center, configuration center, backup center, security center, and fault management center to provide consistent infrastructure management service and a zero-touch experience for massive edge clouds. Common Edge provides open, flexible, intelligent, and programmable capabilities for 5G and vertical industry by extreme performance, intelligent edge, minimized openness, and trustworthy security. The diversified application layer supports the carrier-class NFVs such as ZTE UPF, Ericsson VBus, Huawei VCU, MEP, and a wide range of third-party OTT applications, including Alibaba AR/VR, Tencent HD Video, Network Destination, CDN, Alibaba Facial Recognition, Tencent Cloud Game, and Honda Autonomous Driving. For example, in the precision cloud deployment scenario of ZTE, the Common Edge hardware platform can be used from access to convergence to the central equipment room. The resources occupied can be abridged as required. For example, ZTE fixed access equipment OLT and ZTE RAN equipment BBU and third-party MEC server could use it. PCIe adding card is also compatible with Intel, Naval, NVIDIA, Xilinx, and other type of FPGA, GPU, ASIC cards. In the convergence equipment side, the all-in-one rack can be used to meet the deployment requirements to multiple nodes and multiple scenarios, including distributed storage and MEP. Of course, it can meet the requirements of various application scenarios in the central equipment side. Then, what is the all-in-one architecture? First, it has a physical cabinet, and the core server, switch router, firewall are all integrated inside the cabinet. Also, it has MEP software components. All-in-one cabinet has three capabilities: flexible sitting location, highly integrated and small space occupation, low requirements on room, no need for rack. Rapid deployment. All hardware and software could be deployed according to the demand using automated deployment tool. Simplified O&M. It uses intelligent mechanisms to decrease the complexity of O&M, to save the investment of O&M. Finally, edge node could realize the unattended O&M mode. Here is an application case for autonomous driving. We deployed an embedded MEC inside OLT. Then we deployed 5G UPF and a navigation system that installed in MEC. Operation Center controls the remote vehicle through MEC via 10 GB PON9. Vehicle is controlled via 5G. The highlight of this case is embedded MEC in OLT doesn't require extra space for access office and shares resources with OLT, which has flexible deployment with lower cost. With programmable network as the core, the ICT convergence platform is built. Common Edge provides industry-leading capability exposure system architecture, including network capability, edge cloud resource capability, and service enabling capability. For the network capability exposure, local data could be offloaded with more secure private network are built. Meanwhile, more than 100 wireless precision capability are exposed to end user. It accelerates the service innovation. For edge cloud resource capability exposure, it provides edge acceleration resources for third-party applications. For service enabling capability exposure, the Common Edge solution now is widely used in industrial manufacturing, smart grid, car networking, entertainment media, public safety, education, medical, finance, agriculture, etc. It integrates with more than third-party applications. It can synergy with public cloud to accelerate deep convergence of industry. I will give you two samples of capability exposure. First, ZTE and China Telecom Hunan built a model of smart manufacturing. In this case, a MEP platform was built to offload the video traffic and decode all video traffic on MEC. Compared with traditional video services, the MEC local offloading technology reduces the end-to-end latency by 70% to 80%, and the overall transmission bandwidth greatly. In the same way, ZTE cooperates with Guangdong Mobile and Tencent to complete the Edge MEC pilot project for cloud gaming. To improve user experience, the Tencent cloud gaming service is moved to the Edge cloud node for deployment. At the same time, network slicing is used to guarantee the end-to-end game service quality and form effective isolation from other services. Finally, the delay indicator of the cloud gaming is reduced from 120 milliseconds to less than 20 milliseconds, thus improving user experience. In addition, the reduced demands for backbone transmission resources also helps users reduce the investment in resource costs. Objectively, economy benefits. With the coming of 6G era, the network architecture will be significantly transformed. Traditional networks with major connections will continuously transform into cloud network and network with major computing power. The computing power resources of a single site are limited, and the multiple site coordination is required. According to the different service requirements, real-time network conditions, the real-time status of the computing resources, and the dynamic routing to the computing nodes that are different from the client records. The computing tasks are executed. Computing power gives priority to the exploration of new architecture, new protocols, and new technologies for computing and network integration. On the CFN layer above the network layer, the current computing capability and network status are released to the network as routing information. The network routes the computing task packets to the corresponding computing nodes, thus improve more user experience. computing resource utilization, and network efficiency. ZTE will be committed to implementing the computing-first network solution in commercial application scenarios. Thank you for your time for this topic.